In many applications, you collect your data, but when you want to use the data, you don't have much computation power, or even if you have, there is not much of use. So, so what you can do is just you may need to calculate mean of x of t, or autocorrelation function Rx x of t1 and t2. So we need these properties of average of x of t or autocorrelation function of x of t to be time invariant in order to be able to use past data for future or future data for past. For instance, if you want to study what happened a million years ago, you need to assume that some observation you have now, the statistic is same as observation a million years ago. So you need a stationarity here. So wide sense stationary process are used in wide range of applications, and we require the random process to be stationary in mean and the second order statistics. So this is a general non-mathematical definition. Usually I prefer you to write math definition. This is not acceptable, which is true, of course, but in exams and so on, you want to write the math definition. The formal definition is that we say x of t is wide sense stationary if two conditions are satisfied. The mean is constant. The mean of x of t at time t is equal to mean of x of t with a delay t. So this delay applied to your random variable. So if you take mean and delay it, or if you delay it and then take mean, the result is same. The second property is that we want this autocorrelation function, if we apply a delay to both them, to this and this be constant. In other words, we want this property to happen. This one means that this is equal to constant. And this one means, because this is true for all T1, T2, and C. So, for instance, I could replace C, because this should be valid for all C. For example, let's say C equal to minus T1. So in that case, I should get this expression should be equal to R x of T1 minus T1 and T2 minus T1. Obviously, this guy is equal to R x of 0 and T2 minus T1. So we see that these functions should be only a function of the time difference. Or I could have put C is equal to minus T2. In that case, you get R x of T1 minus T2 and 0. So obviously, if your random process is wide sense stationary, its mean should be constant, and its autocorrelation function should be only a function of the time difference between T1 and T2. So in summary, if in many, because these here you have to write RXX, T1, T2, and so many people, including us, we abbreviate this one. And hereafter, the autocorrelation function, if we know that the random process is wide sense stationary, we don't need to write two time index. Only we write this one. And by definition, this is equal to, this abbreviated one is equal to mean of x at time 2 and mean of x at time 0 and a conjugate on the top of it. Because we know it's wide sense stationary, this should be true for all, this should be equal for all added delays. So I could add here plus any time c and then plus any time c. So you could use this as definition as well. So this is equivalent to this one or is equivalent to this one, provided that this is true for all CO. So the autocorrelation function for wide sense stationary processes is always equal to that, or is that, or also you can write it mean of x of t and then x conjugate of t minus 2 using the same definition. You can. Some people, they abbreviate that and they don't write these extra 0, 0 here, and we do that as well. So hereafter, only for wide sensitization random process, we may use these abbreviated notation. So this means that you take a sample at this time, and this one is taken sample at time 0, or you can use this definition. So this is the definition. Sometimes you can write this one, mean of x of t plus 2 over 2. Half of these two, you put it for here, and then say x conjugate of t minus 2 over 2. This is also correct. So wide sensitization process is also known weak sensitization. These are different terminology which we don't use it, and I don't want you to remember it. Or covariance stationary. This is another term which is used sometimes in other areas. For wide sensitization process, this abbreviated notation is equal to this one. We have said that. And the autocovariance, if you remove the means, you could also have, because the means are constant, is always you have this aspect. So these autocovariance function or autocorrelation function, indeed, they are only a function of 2 and not a function of time t. They are not a function of the center of the two samples. The correlation coefficient, just if you put it there, so rho x of 2 is equal to cxx of 2 and divided by square root of cxx of 0 and then cxx of 0. So as you had before, and then you get this expression. So, and then this number for is always magnitude of that, magnitude of this rho is always smaller than or equal 1.